Hello everyone. Before we begin, let me introduce myself briefly. I'm Minhe Ni. I'm the member in Group 73. Today I'm going to be talking about my project report. My project title is Evaluation for Security of Mobile Applications using Multi-Criteria Decision-Making Methods. I will begin by outlining the background, and then I will introduce the overall structure. I will talk details about my research methods and innovation. Finally, I will briefly talk about the prospect and conclusions. With the rapid development of technology, smartphones play an indispensable role in people's lives. People can take pictures, chat, use navigation, do shopping online, and even make mobile payments using the applications in their smartphones. However, while these applications bring convenience to people, there are also various security risks. Are you worried about some malware will leak your privacy? When the software is attacked or there is malware in the phone, the user's privacy will be exposed. Investigations show that Android systems are more vulnerable to malware attacks. Therefore, evaluating the security of mobile applications is the basis of ensuring user privacy. And this project will be based on Android system to build a model to evaluate mobile application security. I made a figure to describe the overall structure and process of this project. Android application security detection usually adopts static analysis, dynamic analysis, and other methods to conduct security analysis on Android application in order to find security vulnerabilities or malicious behaviors. In this project, I will use static analysis to evaluate the security of Android applications. First, we obtain the installation packages of each Android application. These are APK files, and you can see the structure of APK file. We can use reverse engineering to decompile Android manifest.xml to get the list of mobile phone system permissions requested by the application. We combine the permission list with third-party certification and violation records obtained by other information security platforms to establish an AHP model. Afterwards, the method of mixed AHP topsis can be used to obtain the final safety ranking. Next, I will use the new model I built as an example to introduce the AHP model in detail. AHP is one of the most widely used multi-criteria decision-making methods to solve complex multi-criteria problems. The most fundamental principle of AHP is separation, which means hierarchical configuration. There are 4 steps to use AHP method. First, we build a hierarchical model which contains 3 parts. The target level, which is the purpose of decision-making, the problem to be solved, and the criteria level, which contains not necessarily only one level, are the factors to be considered and criteria for decision-making. And the lowest level is alternative level, which are the options we can choose from. And then we build a judgment matrix, which is actually a subject measurement of the relative importance of all the factors in one level under a certain criterion of the previous level or the target level, using the SETI 1 to 9 preference scale shown in this table. This is an example of the application. So the eigenvector of this matrix corresponding to the principal eigenvalue, which is actually the maximum real eigenvalue, can be regarded as a weight vector. Since we want our matrix to be consistent, so it should pass a consistency check with the evaluation metric CR and compare the CR we calculated with the table. In traditional AHP method, we calculate the weight vector layer by layer until the lowest alternative level. And finally, we can get the weight vector of all our alternatives. As I said before, AHP is based on subjective judgment of decision makers themselves, which may somehow deviate from the objective facts. So here we introduce another method called TOPSIS. Let me explain briefly with an example. Bob gets 80 points on the midterm test. How do you know if his score is good or bad? TOPSIS is to find the highest score and the lowest score in the class, then calculate the differences between Bob's score and these two scores, respectively, to get a relative evaluation. The closer to the high score, the better. The general idea of TOPSIS is that we start with a matrix X, where the element Xij is the object performance of ith application, which is the alternative in this case under G's subcriterion, and we normalize it. Next comes the most important step where the combination of the two methods can be achieved. We apply the weight we got in HP for each subcriterion, which takes the importance of the criterion into account. In the step 3, we calculate the best and the worst solution we have under each subcriterion, and calculate how far away of each application with respect to these two solutions in order to get a relevant distance Ci. Finally, we rank all the alternatives according to Ci. Bigger Ci means better solution. Let's talk something about innovation. The two references listed here give me a lot of inspiration. In the first reference, AHP is used to evaluate the credit index of mobile applications, but I found that the AHP method uses subjective scoring by experts. So as I mentioned previously, in step 2, judgment matrix depends entirely on subjective evaluation. I think evaluating the security of an application should require objective evidence. So I looked into the TOPSIS method, which avoids the bias due to subjective preferences or views, and can well describe the comprehensive impact of multiple indicators. With in-depth understanding of the first reference, I found that its AHP model was not well constructed. The subcriteria under the permission were not detailed at all. There was only used high, medium, low to measure the permission. It didn't reflect the benefits of reverse engineering and didn't display and classify the specific permission requirements of mobile applications. So I referred to another article. From the second reference, I know what permissions are called by the application that will affect the security. I sorted them into categories and generated a new subcriteria level: system, network, privacy, cost, and data read and write. Finally, it comes to the prospect and the conclusion. Prospect. First, since I do not have data about malware in my hands, I can only analyze new methods and models from a theoretical perspective. In the future, if relevant data can be collected, I can use case study to prove its advantages. Second, the AHP process can be extended to include more details. Therefore, the proposed model is still possible for improvements. To sum up, the risk of leakage of personal private information through malware grows very high. That's why we attach great importance on the security of mobile phone applications. This project uses reverse engineering to analyze the permission list of mobile applications and combines the multi-criteria decision-making method to effectively evaluate the security of the mobile application and manage the third-party software market, aiming at protecting everyone's privacy. Thank you for watching.